Paragraph 1. Electric vehicles (EVs) are about to become a thing of the past thanks to Toyota's all-new engine type, which is completely unprecedented. This groundbreaking engine, which Toyota has been diligently working on, is said to be the most eco-friendly engine in existence. So buckle up and get ready for a complete turnaround in the world of cars as we delve into Toyota's innovative engine, one that could potentially disrupt the entire EV industry. Paragraph 2. The engine Toyota is developing is, believe it or not, a water-powered engine. It bears some resemblance to their fuel cell electric vehicles, (FCEVs), like the Toyota Mirai, and hydrogen-powered internal combustion engines such as the 1.6 hydrogen 3-cylinder they've recently unveiled. Historically, water engines have been a long-standing aspiration in the automotive industry, promising substantial benefits over conventional engines and EVs. Despite countless attempts to make water-powered engines practical and reliable for daily use, success has remained elusive, until now. Toyota's new water engine, backed by proper funding and rigorous testing under all conceivable conditions, aims to change that narrative. Paragraph 3. How does the water engine work? For all intents and purposes, the engine is akin to an HHO generator, with only a few modifications that make it better suited for vehicular use. It closely resembles the hydrogen combustion engine found in the Toyota Yaris GRH2, except that it processes hydrogen internally. By leveraging electrolysis, the engine separates hydrogen from oxygen in water. Electrodes in the water tank emit high voltages to create the chemical reaction necessary to separate the H2O molecules. Because the hydrogen is contained within the water itself when stored, there's no need for the heavily armored tanks required by FCEVs and hydrogen combustion engines, which struggle to contain pure hydrogen. Paragraph 4. The process of powering the vehicle bears similarities to hydrogen combustion engines. After separation from oxygen, hydrogen is sent to the engine, where it combusts similarly to compressed natural gas (CNG). The engine components such as fuel injectors, cylinder heads, pistons, and valves need reinforcement due to hydrogen's highly combustible nature. Despite these modifications, the overall operation of the water engine aligns closely with CNG-powered engines. Paragraph 5. What are the environmental benefits? First, the water engine is almost entirely zero-emission, comparable to EVs, but far more convenient. Unlike EVs, which depend on charging infrastructure, water engines only require access to diluted water for refueling, at minimal cost. Additionally, mainstream adoption of this technology could significantly reduce the need for oil extraction, confining fossil fuel usage primarily to heavy machinery and power production. It would also eliminate the need to mine rare earth metals, a process that heavily pollutes surrounding ecosystems, rendering them uninhabitable. Paragraph 6. When compared to hydrogen combustion engines and FCEVs, marketed as zero-emissions technologies, water engines emerge as superior. Storing water is far easier and less expensive than storing pure hydrogen, which requires highly specific conditions, robust containment systems, and substantial financial investment. Hydrogen, being a volatile gas, is challenging to store safely, while water can be kept in simple, inexpensive plastic containers. Moreover, hydrogen acquisition and storage are prohibitively expensive, adding to the already high costs of hydrogen-powered vehicles. Paragraph 7. From a practical perspective, water engines are indeed viable for daily use. They are not underpowered, as some might assume, performing on par with most gasoline engines. In fact, they could surpass traditional internal combustion engines in power output, potentially generating up to 3 times more megajoules of energy than gasoline engines. Additionally, they are safer since they don't require the storage of highly combustible fuels within the vehicle, marking a significant leap forward in both performance and safety for the automotive industry. Paragraph 8. There's no need to worry about water-powered cars catching fire or exploding like malfunctioning fireworks. These engines are easy to produce, with relatively simple mechanical designs that are only slightly more complex than regular gasoline engines. They are much simpler and cheaper to manufacture compared to EVs and FCEVs. Due to their nature, they could be an excellent option for motorizing less developed countries that lack abundant oil resources. In fact, an Iranian scientist named Aladdin Qasimi successfully converted his Peugeot 405 to run on water, demonstrating the concept's feasibility. His innovative conversion turned an old car into a technological marvel. Imagine what a company like Toyota could achieve with proper funding if a single individual could create a daily drivable water-powered car in a modest setting. Paragraph 9. In addition to being easy to produce, water-powered engines are incredibly economical compared to gas-powered vehicles and EVs. Cassimi's modified Peugeot 405 averaged between 30 and 40 miles per gallon of water, figures the car's original petrol engine could never achieve. Hypothetically, future water-powered engines could achieve over 80 miles per gallon without sacrificing performance, making their running costs even lower than initially anticipated. However, since no mainstream versions of this engine type exist, and no major car manufacturers other than Toyota seem to be working on it, the question arises, are water engines the future of transportation? Paragraph 10. The answer is complex. Hypothetically, water engines could be the future of vehicles, but several challenges must be addressed. Logistically, while infrastructure adjustments would be minimal, the technology is still highly experimental. Many so-called functional prototypes have been unreliable, with mediocre daily usability. Furthermore, while using water as fuel seems promising, the process of separating it into hydrogen and oxygen raises safety concerns. As previously mentioned, hydrogen is highly volatile, and even minor system leaks can be dangerous or even fatal. Paragraph 11. Another concern is resistance from powerful industries. Even if Toyota produces a reliable and safe water-powered car, it might face opposition from lithium mining companies, battery manufacturers, and especially oil companies. A widespread shift to water as a fuel would drastically reduce fossil fuel dependency and minimize the need for rare and expensive materials like cobalt and lithium. This would threaten the profitability of major corporations like Rio Tinto, which could take drastic measures to prevent the development and adoption of such engines. Paragraph 12. If this sounds far-fetched, consider the case of Stanley Allen Meyer, the inventor of the first officially recognized fully functional water-powered car. Meyer and his brother claimed he received constant threats, allegedly from representatives of oil companies threatened by his innovation. Meyer even reported being offered millions to abandon his invention and destroy all related plans. Despite this, he continued advocating for his engine until his sudden and mysterious death. Meyer reportedly ran out of a restaurant clutching his throat during a meeting with two Belgian businessmen and told his brother he had been poisoned before passing away. Official records attribute his death to a brain aneurysm, but the incident remains disputed. Strangely, just days after his death, Meyer's car and engine plans were stolen from his garage and never recovered. Paragraph 13. While Toyota's potential involvement in developing a water engine is exciting, it's unclear if the project will ever come to fruition. If Toyota is working on such an engine, they are likely doing so in complete secrecy, which would explain the lack of official confirmation. As much as the idea of a water-powered car excites enthusiasts, history suggests the road to such innovation is fraught with challenges and resistance from powerful entities.